Welcome to Correlations and Other Statistical Inferences, brought to you by me, Todd Levenenko, owner and consultant for TWL ICT Solutions. In this episode, we will look at what happens when the data set is perfect. Yes, funny things do happen when we're dealing with perfect data using statistical packages. To calculate the perfect equation, operating in a data range of minus 50 to plus 50, where I will be printing x, and the function of x will be 3 times x plus 40.5. And it will write to a file, and then it will close. Okay, let us begin. As with previous versions, I am using our version 3.4.4, someone to lean on. In this version of linear relationships, I am going to be looking at a pure relationship as defined in the previous slide. As before, I will load the following libraries. And proceed to load linear.csv file to the variable name linear. We can view the linear file, and as you can see, it is not random. We have no random values in this mix, and it's quite predictable what the value of y will be pending the value of x. As before, I will assign x and y to linear $x and linear $y. And as a result of that, I shall plot it. And as you can see, it's a perfectly straight line. The summary of linear is going to show a perfect relationship. The median and mean for x and for y are identical. That is, x is minus 0.5 for median as well as mean, and y is 39.00 for the median as well as the mean. As expected, the chord test will give us a value of 1. The p-value is basically 0. And the 95% confidence interval is 1 to 1. I will proceed with creating a data frame, and I am going to put the model as follows. It's a linear model with the function of x, that being y, proportional to x. As a result of that, there'll be something different coming out of the summary model. The summary model is going to give us a warning message stating that it's an essentially perfect fit, and the summary may be unreliable. Well, we could see from here that the t-value is infinitely high. The standard error is basically 0. And the probability of the absolute value of t being greater is basically 0, with a significance of 3 stars, which suggests that it's a perfect fit. So we could see the intercept is 40.5 and x is 3, which is our equation, 3x plus 40.5. If we plot this model, you basically see that the residual to the fitted is pretty well 0. The normal Q is pretty well a straight line, which suggests that the standard deviation or standard residuals against the theoretical quantities is basically identical. We see that there is a value of 2. Second value seems to be an outliner, but really I wouldn't worry about it. You can see the scale location, fitted values against the square root of standard residuals is basically 0. And here we see the Cook's distance. Here we have a value of 0 for the standardized residuals and against the leveraged linear model y to the power of x. And we could see that this second dot here, 2, which is related to this value here, for some reason being determined it's outside of the Cook's distance, which is 1. So it's an outliner and it should be dealt with. Interesting how that comes about. Again, in the summary model, essentially a perfect fit, so the summary may be unreliable, and therefore these plots may show unreliability. So this number 2 here in the data set is really questionable, and the 1 here in the data set is also interesting to observe. As well as the 94, but that's kind of irrelevant. Anyway, so what did we learn from this? Well, what we could say from this exercise is that when you are dealing with a model that is perfect, unexpected results can occur in R. It is a statistical package, and it's using statistical inference to determine certain values, and as a result of that, on a perfect fit, those algorithms may not necessarily perform the way it should. So we have to be careful when we're dealing with near perfect data. Fortunately, in many cases when it comes to scientific inquiry, perfect data is not that perfect. Anyways, I hope this little presentation has given you some direction on expectations around statistical variances. Thank you for watching, and have a great day.